Hi, today I'll be discussing about reducing the deployment cost of edge server for a service provider. Many of the research has been done to look into the applications of computation offloading of mobile devices with the assumption that the edge server has already been deployed. However, how to deploy the server cost effectively is not an easy task. We will first look into the architecture of edge computing. One is base station based, which means that the edge servers are co-located in the base station. The other is cloudlet based, which means that the edge servers are decoupled from the base stations and exist as a cluster of redundant machines available for computation and offloading for edge devices. We will look into the three broad themes. First is how do we price our services? Second is where should we deploy our edge servers? And third is how should we allocate our resources? For service pricing, the first method is that we can use is incentive compatible auction mechanism, where the users send their bid. The highest price they are willing to pay for the resources. The winning bids will of course get the resources. Second is stochastic control, which requires the request to be sent to the managing platform, where it makes the allocation decision based on the statistics shared by the cloudlets, such as the network workload and resource availability. Now we shall evaluate. ICMA uses auction model to decide whether the user request will be served. However, for stochastic control, it will always ensure that the user's request will be served, but at the lowest global cost. The stochastic control is more realistic as it differentiates service types of different cloudlets as well as their computation capacity. For ICME, the auction model will become more complicated with this increase in parameters, as each of these service types must be auctioned separately. Now we will talk about the server placement. Before we dive into the methods, it is perhaps relevant to understand the energy evaluation model. The idleness and underutilization of a server contributes a lot to the energy consumption. Particle swarm optimization can be used where different possible placements are encoded as particles, and at each iteration the particle will move towards the global optimal solution. The movement is determined by the three factors as shown. Network snapshot method recognizes that the network traffic is dynamic and hence snapshots of the network at different timestamps are considered for the final placement. Capable algorithms suggest that we can combine the deployment and network latency costs and try to minimize this sum. AP ranking recognizes that if the cloudlet does not have a good connection, they will not be fully utilized due to congested link. Hence, placement should be decided after ranking the location by these four indicators. Resource requirement forecasting recognizes that network traffic is highly dependent on the type of request sent. Where will the next destination be, and how to allocate the resources accordingly. Now we shall evaluate. Most of these methods uses historical data or predictive modeling to ensure the robustness of the edge server placement, allowing it to adapt to the dynamic environment. However, as the society evolves, the network traffic pattern and density will change over time, and edge servers have to be redeployed to adapt, therefore increasing the deployment cost over time. The AP ranking works by minimizing the edge placement cost by finding the best connectivity to prevent the congested link, and this will avoid the redundant deployment, which not only results in deployment cost, but worsen overall network performance due to congested link. Granted, the resource forecasting will help to determine the number of resources to be placed at the location after deployment. Next, we will be discussing about resource allocation. First is by allocating the task with the workload. The other method is dynamically balancing the workload by using virtual machine method. First is mixed integer linear programming, where the decision will be made as to who the request will be sent to, the local cloudlets or the global cloudlets. Now we'll be talking about the virtual machine. So how does the virtual machine works in allocating resources? The cloudlet with utilization higher than the threshold will pass some of its VM to the others. The cloudlet with lower than threshold will also have its VM passed to others so that it can be freed, and idleness power consumption can be reduced. First is Markov decision process, which uses a controller to decide the resource allocation based on the user identities and the status of the cloudlets. Second is the green energy aware avatar placement, which considers the scenario where base stations are supplied by green energy such as solar. GAP will try to minimize the broad energy by migrating the VM to other cloudlets with maximum residual green energy to balance the energy gaps. Now we shall evaluate. As edge computing evolved, global cloudlets have become more and more prevalent, and therefore they should be included in the analysis. Furthermore, as the world is moving towards green technology, more AP will be powered by solar. Therefore, making a decision based on the residual green energy is getting more and more relevant. VM migration techniques will make it more efficient to transfer workloads across different cloudlets and allow for more user mobility. And now for the discussion. Future research can be done to ensure the whole allocation is distributed and does not need an intermediary, as it will increase the network latency and cause a single point of failure. We have evaluated three broad teams that work hand in hand to reduce the cost for the service provider. The edge server placement will determine the best placement for the edge servers, such as AP ranking. The resource allocation and pricing will then determine how to allocate the resources to reduce energy cost. With that, thank you for joining in this discussion.